Hi, I'm Tim. In a previous video, I'll show you the card up here. We built the Guillow Arrow, converted to radio control. Join me as we build a second version of the Arrow here with some improvements and making things a little bit different, hopefully a little bit prettier with the decals. Let's get to it. Hi, I'm Tim. Thank you for joining me today. As always, if you like what you see here, please subscribe, hit the like button. That helps a lot with YouTube and future videos to bring to you. What we're going to do in this video is we're going to build the Guillow Arrow, one of their contest type model airplanes. Now you'll look up here, there's a card. I built an Arrow, installed radio control equipment about a week ago. It flies fine. Let's take a look at how that flies right now. The model flies really well. Here is that model, and this is the Arrow converted with radio control equipment. The radio control equipment we use is the ParkZone line of ultra micro radio equipment. There's a previous video that I'll give the card up here that explains this ParkZone system in detail from Horizon Hobby. This brick has a receiver, electronic speed control, 2 linear servos, and is connected to this geared electric motor. This was taken off of another E-Flight indoor flyer, but the radios are remarkable, and is powered by a rechargeable single-cell lithium battery. So this electronic system is the same thing in this Arrow. We know that it flies well, so what I'm going to do in this video is go through a second build of the Arrow, not quite as much detail as the first one, but rather explain some differences, because I like to build what I call a rough prototype, see how it works. It works fine. Then with the second one, I can make it look more attractive, make some changes that I learned from the first one, which is kind of a test article for lack of a better term. So let's kind of discuss what I'll be thinking about as I build this second version of the Arrow. The motor installation is correct with a little bit of down thrust, a little bit of right thrust. That is a good entry point. Notice the motor is a little bit far forward, just sticks out a bit, which is okay for a test model. I think I'm going to move that in, and I think I'll be able to put a balsa cowl on the front that'll cover it, so just the prop shaft will stick through. I think that'll look a little bit better. On this prototype, I put a soft balsa, carved balsa on the top of the cowling. It added a lot of strength, not much weight at all. I'm going to extend that back to the wing leading edge. This right now is 1/16 inch balsa. It is bending a little bit from the applied plastic covering. I think the weight is okay to extend that back with a balsa. On the fill for where the wing is installed on the fuselage, I'll fill that in with balsa just so it looks better from an appearance viewpoint. Going back to the canopy, there'll be a profile pilot that will add to the appearance, a small windshield to go in front that'll make it look okay. Underneath, the installation of the electronics of the motor will be the same. The installation works out just fine. The control rods that I described in the other video work just fine to control the control surfaces. Notice the 3/16 inch balsa that's a little bit bigger than the 1/8 inch balsa shown in the plans. That is good, needed for strength. Now notice on the back, as I was building this, I was designing it for radio control flight. So the plans will show a complete horizontal stabilizer. There's no cutout for the elevator because it's a free flight model. So I just estimated a distance here for the elevator, built the elevator, but what I did was I built an elevator straight through. So that works fine. The problem is I was locked into this fairly large cutout in the fin to allow the elevator to go up and down, as well as kind of an odd shape in the back of the rudder. What I'll do on this variant is I'll just have the standard V cutout that you see in about every other airplane, so the fin can go down to the fuselage, the elevator can go up and down without interfering with that. It'll give it a much more attractive, natural look. The elevator is a big enough surface for flight. There's no problem with that. The rudder is fine, but I think I may make the rudder just a little bit bigger, just extend it out a little bit to have a little bit more area to help with the turning of the model. In addition, the landing gear is a simple installation, epoxied in. It works fine. These wheels weigh nothing. However, I just eyeballed the strength of the music wire. I can get away with a little bit lighter, thinner music wire. That will save a little bit of weight. This wire is heavy. I can just feel it on the airplane. The other thing we're going to do, because we want to make the model look attractive, we'll spend a little bit more time with the color scheme and the decorations. So what I'll do is I'll go through the process of creating waterslide decals on your computer. We'll get some images off the internet, make decals out of them, apply them to the model, show you how to do that. I think that will look nice. Then some stripes, some variation of color on the fuselage, just to add to the visual appeal. So I'm looking forward to a second build of the Arrow. This is just a wonderful flying model. Couldn't be any happier with it. And just a few tweaks, I think it'll make it look quite nice. We made some good progress on this second version of the Arrow. So let's go through the framework, because I'm going to start covering here probably tomorrow. So this is the wing. The wing is the same as the previous version. There's no ailerons. There's really nothing new to report on this. Again, I remind everybody building one of these Guillow airplanes, this 1/32 inch balsa, just as small as that, at the dihedral joint in the middle, makes a huge difference for strengthening the wing. And also one thing that we'll do a little bit different on this one, as we put the wing in the center section, we'll fill in this whole area with balsa wood to make it a streamlined section of the fuselage, as opposed we did not do that on the other version of the Arrow. The stabilizer and elevator are done, and you can see this has the lifting airfoil section characteristic of the Arrow. One big change I did on this was to have the cutout of the elevators here. If you look on the original Arrow, because I was building it this time, the elevator is straight through. You don't have this V-cut. What that necessitated with the elevator straight through was this huge cutout on the fin and rudder to allow the elevator to go up and down. With the V cutout, we don't have to worry about that because it can go up and down between the rudder. I think it'll make it a little bit more attractive on the back of the airplane. The fuselage is quite similar to the original Arrow. I'll have to put the stringers on the top here, but the same with the 1/32 inch balsa over the original framework on the plans. What I did do was the top, I had very soft, lightweight balsa. You'll notice on this fuselage, the balsa was just the front part, and this was stringers. You can see where it's sagging a little bit from the covering. It was just a smarter move to extend the balsa all the way back. This provides a lot of strength on the top of the fuselage, and I think it'll look a lot better. The wing goes here, and then stringers, etc., for the fuselage going back. The radio equipment is installed. As before, I built a little balsa shelf to glue this onto. The motor, you'll notice if you look on the side, is a little bit further back, so just the prop shaft is sticking out. I intend to put some balsa on front, maybe do a little bit of work with the radiator, because this airplane will be a little bit more decorative than the other Arrow, now that we know that it flies well. This is a good time to do another update on our Arrow, the second update of the Arrow to radio control flight. Here's a fuselage here. We've covered the tail surfaces. We're going to cover the fuselage next. And this is an important point to discuss why we cover the tails and not the regular fuselage. It's because we have to install the control rod linkages for the rudder and elevator. And it is much, much easier to do the control rod installation without the covering, so we can adjust it, see where everything goes. So let's take a look at the front here. And the electronics, well, first of all, the motor is right here. You notice I removed a little bit of the top block in front of the nose. The reason for this is I'm going to have to add a little bit of nose weight. The tail's coming out a little bit heavier than I had expected. It'll be easier to do that with the block removed, and I'll glue everything back in place. Here's the control units with the elevator and rudder servos. Notice that I have the very thin music wire with these guide tubes epoxied into place to prevent flexing of the control rods. The key thing I want to point out are these two black shrink tubings, because there's one rod in the front, another rod in back. They overlap. I heat shrink the tubing. It's a very easy way to adjust the elevator rudder to the central position, shrink the heat tubing, again, all before you're covered. The other important thing is to see where your control rods exit to the controls. Notice here's a tube guide for the rudder, and you have to go on top of the elevator to get to the rudder. By the same token, for the elevator, it's underneath. There's a guide tube here, and then the control rod in this location. Now, one thing else I want to point out are differences between the two arrows. This is the original one with the red tail. Notice the stabilizer is straight across with the original arrow, just the way I built it. With this one, we have a V configuration of the elevator. What that allows us to do is have a little bit more normal looking rudder because the V is not in the way. I had to do this fairly large cutout on the red rudder because of the straight across elevator. So that was just a little bit of a difference and improvement. The other advantage by having the V cutout of the elevator, I could put the rudder hinge line here. This is a much bigger rudder. I think it's good to have a little bit of extra rudder for turns. Another thing I want to point out, you'll notice that this is a airfoil shaped stabilizer and elevator. That is characteristic of the free flight models of the day to have a lifting stabilizer. I'm sure it was a great idea back for the free flight model for endurance. It is a lot of work building this, and more importantly, it adds a lot of weight. If I were to build another one, I'd recommend to anybody watching this video, the stabilizer and the rudder, just make it out of flat 3/32 inch balsa. You can make a frame if you want to save some weight. There's a pretty big area. The fin and rudder are 32 inch balsa. Just make the elevator and elevator, these are the stabilizer and elevator, the same materials. You'll save weight, complexity, it'll be a lot easier. Remember, the lifting stab provides a little bit of lift. That's why the center of gravity is so far aft. You'll probably have a normal center of gravity a third of the way on the wing. One other point that I'd like to discuss is installation of the landing gear. Now, if you take a look at the landing gear, it's just a straight metal U-bend that is glued into the fuselage at an angle. It's a simple, effective way to do it. But keep in mind, you've got to glue in the landing gear before you start adding the control rods. If you had the control rod linkages in place and not the gear, it'd be very difficult to get that around the rods. So again, just something, thinking through your various construction steps, put in the landing gear before these rods go in with this style of conversion. We'll do now just a quick demonstration of the rudder and elevator. Remember, with these ParkZone electronics, to keep it from going into the bind mode, you want to make sure that it can see your model on the transmitter. So we have Arrow 2 selected. We'll go ahead and connect the little LiPo battery. And elevator up, down, rudder, left, right. You see I've got tons of rudder there, that's good. And then we'll check the motor. And it goes in the right direction. So we're in good shape to go ahead and cover the rest of the fuselage, the wing. I've completed my second build of the Guillow Arrow converted to radio control. Let me talk about a few things that I did to improve the appearance that you can try or experiment on yourself. The first thing I did, you can look in the front, is I put a balsa covering on the nose just for appearance's sake. And then to give it a kind of metallic look, what I used was some insulation tape, silver insulation tape that I got at Home Depot. It's just got a very sticky back. It's a nice kind of chrome fit, and you just use the sticky tape to put that on. And you can use other portions of the model as needed to add for a metallic effect on your model. The other thing I did was more extensive uses of decals. There's a card up here that shows my video on how to make waterslide decals for your RC model airplanes. It's very easy to do with the transparent backing. You can see also, just for fun, I have a little no push on the wing. I have a pilot's name back here by the cockpit. And then on the stabilizer, a no step. So it's an example of just some of the things that you could do with decals. Even on the front, I added a Champion spark plug logo to the front. Also, I'd mentioned earlier, the top of the nose is solid plywood all the way back to the wing center section. This adds strength to the nose section, a little bit of weight, but I think it's a better thing to do. Notice also I did a little bit of balsa fairing work on the front and back to smooth that into the overall profile fit of the airplane. As always, when you build these smaller models, weight is the key. This one came out about a ½ ounce heavier than the other arrow. The other arrow was 2.4 ounces. This is about 2.9 ounces. Part of the reason was the weight with the tail. I get kind of stuck into doing that. And the yellow covering that I used in the wing is just a little bit heavier than the other type of covering that I used. What I've learned doing this is you can see the blue covering is transparent. You can see through it, but the transparent covering is far, far lighter than the solid yellow one. I think if I were to do this again, I'd use transparent covering everywhere just to have a lighter effect. However, I think the model will be okay. We'll find out with a test flight once we do that. The key to successful flight on these smaller models is a good sized wing. This is a 28-inch wingspan. It's got plenty of wingspan for this size model. I think that will be sufficient for this airplane to fly. So we just finished the test flight. The plane is heavy, okay? It comes in at 3 ounces. So I was curious to see if the plane would fly at 3 ounces. 3 ounces is my penciled in weight for the ParkZone electronic ultra-micro equipment. This is right at the upper weight limit. So it was a good experiment to see how heavy you could go. So it flew okay. I think it's just a little bit tail heavy. We could add a little bit more nose weight. It's right at the limits of its power. It's pretty windy around here. It's bouncing around. It's a tight flying area. So as always, the lessons learned are it's a good flying model, but you've got to keep it light. And some of the things I added for appearance and all that stuff, I think look good, but it adds weight, and that just has a cost to the flying characteristics. So again, good luck with your Guillow's conversion. Keep it under 2.5 ounces with everything, the equipment, the battery, and just keep it as light as you possibly can. Good luck.